All right, now this equation looks promising because if you take a quick look, you see that all of these guys are log base 3. Now, the problem that we run into is that we can't just take it as it is right now and say, oh, well, then all the stuff inside equals each other. You would have to have log base 3 of something equal to log base 3 of something else, and then the insides would be equal. So we don't have that, but we're going to get there. The first thing is to remember the properties of logarithms that would allow me to put this power back up top. So on the left side, it's log base 3 of x plus 5 squared. On the right side, we can combine all of these guys, understanding that we would have log base 3 of this coefficient goes back as a power, so that's 7 squared. And then because of the plus here, that means times whatever's inside here. So we're using a couple of properties at the same time, one that puts the coefficient back as a power, and when we have a sum of logs that are the same base, it becomes a product inside that log. And now, because these logs are exactly the same, we can then set their inside pieces equal to each other. Now, if we work this out, just keep in mind that 7 squared is 49 times 9, and we have 98. All right, so the log is gone, and we're focusing just on what's left over, which is a quadratic equation. Not only that, but it's a quadratic equation where you only see x in one spot, and that spot is a square, so we use the square root property. So we take the square root of both sides, remembering plus or minus. All right, so we get x plus 5 is equal to, now remember where 98 came from. 98 came from all this stuff right here. So it factors as 49 times 2. The square root of 49 is 7. So we have plus or minus 7 times the square root of 2. Finish getting x by itself by subtracting 5 to the right side, keeping in mind that when you have a plus or minus already in play, whenever you move things over, put it in front. So I would say negative 5 plus or minus 7 square roots of 2. But you've got to make sure you avoid the temptation of just circling this and saying, I'm done. Go back to the original problem. Pay attention to the restrictions on the domain. Now, when I have a 2 and a 7, that doesn't give me any restriction because log base 3 of 2 is just a number. Log base 3 of 7 is just a number. But over here, when I have a variable, got to be careful. Now, I know that from here, that x plus 5 has to be greater than 0, which means that any solutions that I get must satisfy the inequality, x being greater than negative 5. So let's look at our two solutions. So from here, we have x is equal to negative 5 plus 7 square roots of 2. And the other solution, x equals negative 5 minus 7 square roots of 2. All right, well, I hope it's pretty clear to see that this guy right here is less than negative 5. So this one cannot be a solution. It doesn't satisfy the domain that we have up here where your values have to be greater than negative 5. So looking at the next one, this guy is greater than negative 5. So that will be a solution, and the only solution that we have here. You might say, how do I know that's greater than negative 5? Well, you've got negative 5 right here, plus, well, this is 7 times the square root of 2. The square root of 2 is about 1.4. So this is going to give us something that's close to 10. So it's definitely going to be greater than negative 5. I mean, you're doing negative 5 and you're adding something to it, so it's got to be greater. So that's our one and only one solution. I'm not saying that you could only ever have one solution. I'm just saying for this one, there is just one solution. All right, let's look at another one. Suppose I have e raised to the 2x plus 1 is equal to pi to the x. Yeah, I just wrote e and pi and x all in the same equation. You're going to be okay. Now notice that both of our variables are located up in the power position. So I need to bring them down. The best way to do that is, again, to take the natural log of both sides, applying logs like we've been doing this whole section. Now, notice that on the left, natural log is understood to be base e. With e means these guys are going to reduce, leaving us with the power 2x plus 1. On the right side, you bring the x out in front, so x times the natural log of pi. I don't know what the natural log of pi is. I don't really care. Right now, this is an exact value. And my job is to get x by itself, right? But notice that I have x in two different places. I have x here on the left and x here on the right. So as we saw earlier in this section, get every term with x to one side and get the constants to the other side. Well, 1 is the only constant that I have, so let's just leave them on the left, and let's move the 2x over to the right. So now I have 1 is equal to x times the natural log of pi minus 2x. And as we saw previously, we have a common factor here. So let's take out the x. So x times the natural log of pi minus 2. And to finish getting x by itself, we need to divide both sides by natural log of pi minus 2. So you'd have 1 over the natural log of pi minus 2. And again, this is exact. To get our approximation, let's go over to the calculator and see what it gives us. So 1 divided by big parentheses, natural log of pi, so second power 2 to the pi, minus 2, close up the parentheses, and what do we get? So this is approximately negative 1.169. So I'm going to store this into x. I'm just going to take a moment to check my work. It doesn't take long. So back up at the top, we have e raised to the 2x plus 1. And then we have pi raised to the x. Let's see if we get the same answer. And we do. Huzzah! Totally awesome, right? Well, I bet things can get even more challenging. So stick around.